Hello viewers, in today's class we are going to solve some problems based on definite integrals. So here we'll take this property which is applied to these problems. So if f of x is continuous function, then the integral of f of x from a to b is given by uh, integral from a to b f of a plus b minus x dx, right? So here this property is very useful for evaluating integrals. So here what we do basically is we are given some function f of x, and we have to integrate it from a to b, and we replace this variable x, right? This variable x is replaced by a plus b, that is sum of the lower limit and upper limit minus x, right, in the next step. So here we have this integral from 1 to 2 square root of x divided by square root of 3 minus x plus square root of x, right? So let us integrate this function using this property. So here the value of a is 1 and the value of b is 2, right? So a is 1 and b is 2, and f of x is given by this function, that is square root of x divided by square root of 3 minus x plus square root of x, right? So let us call this integral as I. Clear? So in the next step, what we will do, we will replace this variable x, right? This variable x by a plus b minus x, right? So this x is replaced by a plus b minus x. So x can be replaced by a is 1 and b is 2. So 1 plus 2 minus x, and this is 3 minus x. 1 plus 2 3, so 3 minus x. So in the next step, so we'll write 1 to 2 and square root of x. Now for x we should write 3 minus x. So here we have 3 minus x divided by square root of 3 minus for this x we'll write 3 minus x plus square root of 3 minus x and dx, right? So this is the given integral, and in the next step what we do, we replace the variable x by a plus b minus x. The value of a is 1, the value of b is 2. So 1 plus 2, that is 3, 3 minus x. So here we have written for x we have written 3 minus x, here also for x we have written 3 minus x, and here also we have written x is equal to 3 minus x, right? So now this integral, it becomes 1 to 2, and we have a square root of 3 minus x divided by this is 3 minus 3 plus x. So 3 and 3 get cancelled, so we are left with only x plus square root of 3 minus x, and here we have dx, right? So let us call this integral as 1 and this as 2, right? So this is the original integral which we have to evaluate, and this is the integral obtained by applying this property to this integral, right? So now what we will do, we will add these two integrals, right? So if we add 1 plus 2, so what we will get, we'll have here 1 it is I plus I, right? So I plus I, and here we have 1 to 2 square root of x divided by square root of 3 minus x plus square root of x dx plus, and this integral is 1 to 2, and here we have square root of 3 minus x divided by square root of x plus square root of 3 minus x dx, right? So now this I plus I becomes 2I, and here see the integral is same, that is the limits are same, so we take the integral from 1 to 2, and we have square root of x divided by square root of 3 minus x plus square root of x plus this function, that is square root of 3 minus x divided by square root of x plus square root of 3 minus x dx, right? So we have combined these two terms, and we get this expression. So now this becomes 2I, this is 1 to 2, and we see that these are two functions, and here the denominator is same, so we have here the denominator is square root of 3 minus x plus square root of x, and in the numerator we can write square root of x plus square root of 3 minus x, right? And now we see that the numerator and the denominator both becomes equal, so these two get cancelled, this term and this term get cancelled, and we are left with 1 to 2 and dx, right? Okay, so now this can easily be evaluated, so we can write 2I, and the integral of 1, that is integral of 1 dx, is simply x, and the limits are from 1 to 2, so we have 2I, and here we have 2 minus 1, and 2I is equal to 1, so I is equal to half, right? So the value of this integral is half. Now let us solve this problem, and here we have integral from pi by 6 to pi by 3 1 over 1 plus square root of cot x dx, right? So here also we'll evaluate this definite integral with the help of this property. So let us first call this integral as I, and here the value of a is pi by 6, the value of b is pi by 3. So what we have to do in order to apply this property, so here we'll find a plus b minus x, so this is pi by 6 plus pi by 3 minus x, and this is 6, and pi plus 2 pi minus x, so we have 3 pi by 6 minus x, so we have pi by 2 minus x. So it means the value of a plus b minus x is pi by 2 minus x. So therefore in the next step what we have to do, we have to write integral from pi by 6 to pi by 3, and we have to replace this variable x by this term, right? So here we have cot of pi by 2 minus x, and here we have dx. So this becomes integral pi by 6 to pi by 3 1 over 1 plus square root of cot pi by 2 minus x is square root of 10x, right? So square root of cot pi by 2 minus x is square root of 10x, because cot pi by 2 minus theta is equal to 10 theta, right? So now this integral can further be expressed as 1 over 1 plus 1 over square root of cot x dx, and taking LCM and taking this square root of cot x to the numerator, we can write I is equal to integral pi by 6 to pi by 3, and we have square root of cot x divided by square root of cot x plus 1 dx, and let us call it equation number 2. So now in the third step, what we will do, we'll add these two integrals. So adding 1 and 2, we get I plus I. So here we have I and here we have I, so I plus I, and here we have pi by 6 to pi by 3, 1 over 1 plus square root of cot x dx plus integral from pi by 6 to pi by 3, and we have square root of cot x divided by square root of cot x plus 1 dx, right? So I plus I becomes 2i, and here we have pi by 6 to pi by 3, and we can write 1 over 1 plus square root of cot x plus square root of cot x divided by square root of cot x plus 1 and dx, right? So combining these two functions here, and if we take the LCM, we see that this is integral from pi by 6 to pi by 3, so this term and this term are same, so we'll simply add the numerator. So we have 1 plus square root of cot x divided by 1 plus square root of cot x dx, right? So here the numerator and denominator are same, so these two terms get cancelled, so we are left with integral from pi by 6 to pi by 3 dx, right? So the integral of 1 dx is x, so we have 2i, and here we have x, and the limits are from pi by 6 to pi by 3. So we can now write 2i is equal to pi by 3 minus pi by 6, and this is 2i, and we have 6 is the LCM, so this is 2 pi minus pi, so 2i is pi by 6 and I is equal to pi over 12, right? So the value of this definite integral is pi over 12.